Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at part 3 of the market basket analysis. To refresh what we had done earlier, in part 1, we spoke about the EDA or exploratory data analysis of market basket analysis. In part 2, we focused on the ECLAT algorithm. ECLAT stands for Equivalence Class Transformation Algorithm. In part 3, we'll be looking at the Apriori algorithm. Now, even before I demonstrate the Apriori algorithm, what I will do is call the library A rules. I've already installed this particular library, so I'm not going to reinstall this. I'm just going to call the library A rules. In case you have not installed the library, I request you to install this particular library by using the command install.packages, open bracket, double quotes, A rules, close the double quotes, close the parenthesis, install this particular library. Once you install this particular library and call the library A rules, in the next step, what you can do is you can create an object which is called as transactions. How will you create this object? There is a data set which comes inbuilt with the A rules library. I'm going to assign this data set groceries to the object transactions. Now that we have assigned the data set, now that we have assigned the groceries data set to the transactions object, what we will be doing is we will be looking at the frequent item sets which customers buy. You're a customer, you walk into any of the retail outlets, there's a good chance that you pick up multiple items. You may pick up domestic eggs with sauce, or you may buy bread and jam, you may buy other items. Right? We are interested in looking at these patterns or associations wherein customers buy multiple items. Now, in a brick and mortar world, perhaps it's very easy for a shopkeeper to say which two items sell very well together. But in today's day and age, when you have millions and millions of items, it's a bit difficult to understand which two items or which three items the customers buy. And therefore, what we will be doing is we will be looking at what is called as frequent item sets. As the word itself suggests, frequent and item sets. Those items which customers buy together, like shoes and belt along with a shirt, right? These are items which are perhaps frequently selling. These two items, these two or three items which are selling together, once you know that product A and product B are selling very well together, you can cross-sell one item along with the other. This also helps the store managers. This helps the store managers to decide product placements in the aisle. So without wasting too much time, let me just run the ECLAT function. This is the ECLAT function, which I will be running on the data set transactions. Let me just check my spelling. The data set is transactions. I'll have to specify the parameter here. This is the parameter keyword. I will feed a list. Now, I will give the support value. This is the minimum support that I am providing as 0.075. Now, if you relax this number, if you provide a lower support value, you can see a lot of frequent item sets being displayed. On the other hand, if you're slightly more aggressive with this number, higher the support, naturally you see fewer items being shown to you at a later stage. So please feel free to experiment with this number support. I'm specifying 0.075 as the support. Next, I will also be specifying the max length as 15. So these are the things that I will be looking at. I'll be looking at a minimum support of 0.075 and a maximum length of 15. Now, what I'll do is I will store the output of ECLAT in an object, right? The output needs a place to live. So I can create an object called as frequent item sets. Frequent item sets. So just to explain this command once again, eclat is the function. That function will run on the transactions data set, and it will look for this particular condition. That is, the minimum support is 0.075 and the maximum length that I am providing is 15, right? So let me go ahead and execute this. So the code has run successfully, and you can see here it says it is writing 16 rules. So eclat function has created 16 rules, and it will be storing these 16 rules in an object called as frequent item sets. Now, let me just clear the screen and inspect the rules of the eclat function. So I can just use the inspect command and pass this particular object, which is known as frequent items. So there is a spelling mistake. Looks like I've not declared the object name correctly. So it is frequent item sets. If you see here, I had created the object called as frequent item sets, but here I'm providing frequent items, which is wrong, and therefore R is not able to understand what. Fine. Let me just go ahead and change this. It is going to be inspect frequent item sets. Right. Once I click on frequent item sets, you can see here it lists the items which are getting sold. That is whole milk, other vegetables, rolls and buns. It also gives the corresponding support and count here. To my surprise, what had I requested for? I had actually requested for item sets. I had requested for item sets, which means multiple products which are sold together. But my conclusion when I look at this is most frequent item sets. I repeat, most frequent item sets correspond to the most frequent items, as there are no more than 2 items in the item sets. You have barely one item, you have only one item here, and therefore the support here is not for a set of products, it is for one particular product itself, right? This gives me a high level perspective about which are the items which are sold prominently. Now, what I'll do at this stage is, you can see a whole lot of items here like whole milk, other vegetables, rolls and buns, yogurt, soda, so on and so forth. I want to create rules for these items. Now, to create the rules, I am going to run an algorithm which is known as Apriori. Right? So this is the algorithm which I will be running. It's called as Apriori, and you can feed the data set. This particular data set, as I told you earlier, comes inbuilt with the A rules library. So Apriori function will be run on the groceries data set. You can specify the parameter here. The parameter values you need to specify. So let me just provide list of. I need to provide the support here. Support equals 0.009. Confidence equals 0.25. Confidence equals 0.25. And finally, the minimum length. Please note this point. The minimum length is 2, which means there should be an association of, there should be at least 2 items in the basket, right? I don't want the frequency. I don't need the support and such things wherein the person has bought only one product, where I want to find out association of minimum of 2 products, which means there can be more than 2 products as well. There could be 3, 4, 5, 6, 7, so on and so forth. So it's a very, very simple function, as you can see here. There's a simple command that you can give, that is Apriori. You have to feed the data set, and the parameter values is what you will be declaring. Let me just go ahead and execute this particular command. My Apriori function has run, and it is just giving me some basic information here. This is very, very interesting. Let me draw your attention to this particular line. It says writing 224 rules. very, very interesting. Apriori algorithm has found 224 rules. When we say rules, each rule represents product associations. I do not know for sure whether there are 2 products or 3 products or more than 3 products that it has found out, but it's very, very interesting to know that there are 224 rules that Apriori has been able to dig out from the data set. And it has not taken a long time to extract 224 rules. As you can see, it has hardly taken milliseconds. So this is about Apriori. Now, I'm not able to see the rules. Now, to fetch the rules, what I will be doing is I will recall this particular command, which is Apriori. I am going to store this in an object and call it as rules. Remember, rules is like a bucket. It is like a container which will contain all the 224 rules that Apriori algorithm has extracted. Let me go ahead and execute this. It just gives me the same information as it had given earlier. It says that there are 224 rules. Fair enough. Now, what I am going to do is clear the screen and look at the summary of the rules. I want to see the summary of rules. So use the summary function. Summary is the function and rules is the object wherein Apriori output has been saved. So summary of rules. Let me see what does this give me. You can just get a high-level perspective of what is going on here. As you can see here, 111. There are 111 rules wherein 2 items, product association for 2 items have been found. There are 113 rules wherein product associations for 3 items have been found. If you take the sum of these 2 numbers, 111 and 113, you will be getting 224 as the total number of rules. So out of 224 rules, 111 rules correspond to a situation wherein 2 products have been bought by the customers. Similarly, 113 rules correspond to 3 products being brought by the customer. If you look at the average basket size, it's around 2.5, right? The median basket size would be around 3. This is what I get to learn from this. There are other important measures as well, like support. We have discussed yesterday that support represents how popular an item is. Support corresponds to how popular an item is. There's another way of interpreting, since we are talking about item sets. Now, what does support mean in this context? It shows the frequency of patterns. I repeat, it shows the frequency of patterns in the rule. It is a percentage. It's just simply a percentage of transactions that contain both the products, which means if you're looking at those people who have purchased oranges and apples, out of 10,000 transactions, 10,000 will be in the denominator, and let us say 1,000 people have bought both oranges as well as apples. So 1,000 will be in the numerator. So support will be equal to 1,000 divided by 10,000. 1,000 is the number of people who have purchased both apples as well as oranges. 10,000 will be the denominator, because that represents the total number of transactions. So that is about support. Now, what about the mean support? Let's look at the mean support. It is 1.6%, roughly around 1.6. That's what I can say. Now, let us look at confidence, which is again a very, very important metric. Now, what is this confidence, right? Confidence represents the strength of implication of a rule. I repeat, it is the strength of implication of a rule. Let me look at the mean confidence level. To carry forward that analogy of customers buying apples and oranges, in this context, what is confidence? Confidence can be evaluated by using a simple formula, and that is number of transactions wherein people purchased both apples and oranges. Let us say that is 700. So 700 people bought both apples as well as oranges. So 700 will be in the numerator divided by number of transactions that bought only apple. I repeat, in the denominator, you'll be looking at the number of transactions wherein customers bought only apple, right? So this represents the confidence. Now, lift is very, very important because of multiple reasons. I've discussed this earlier. Lift value of exactly 1 means that products A and B, it can be any two products, product A and B are independent of each other. Very, very important. If lift value is bigger than 1, it means that product A and B are positively correlated. Product A and B are positively correlated, which means if more and more people buy apple, there is a tendency for them to also buy orange, right? That is a simple way of interpreting lift. Lift greater than 1 indicates product A and B are positively related. A lift value of smaller than 1 indicates that product A and B are negatively correlated. They do not go well together. So when you look at the average support, it is around 1.6. When you look at the confidence level, when you look at the average confidence level, it is 37%. And when you look at the mean lift, it is 1.94. You can round it off and say it is approximately 2. So this is a high-level summary that Apriori. This is a high-level summary of the output of Apriori. Now let's just go ahead in this discussion. Now we have run the Apriori function. We have looked at the summary. Now it is time for us to inspect the top 5 rules. I am saying top 5 rules. This is entirely under your control. If you're interested in examining the top 10 or top 25 rules, please feel free. Now, how do you do this? Again, I am going to run the inspect function. This inspect function, I am going to pass another function, inspect of. Let me just correct the spelling. It's inspect of head of. You want to sort the rules. You want to sort the rules. Remember, we have stored the output of Apriori in an object called as rules. You can put a comma here and say by lift value. Should it always be lift? Not necessary. It can be based on support or confidence. It's entirely under the control of the user. Please feel free to provide any of these 3 metrics. If you can either use lift or confidence or support, depending upon what you want. I'm interested in sorting the rules based on the lift value, and therefore I'm providing lift in the by statement. The question is, how many rules do I want to extract? I want to extract 5 rules here. Therefore, I'm providing 5, right? So I've opened 3 brackets here. I made sure that I have used 3 brackets to close this particular function. Very interesting. What do you see here? The moment you see here, the moment you execute this particular command, it returns the 5 major rules, right? You can see here in LHS. LHS also we refer to LHS as antecedent, and RHS is referred to as consequent. LHS corresponds to antecedent, RHS corresponds to, my apologies, LHS corresponds to antecedent and RHS corresponds to consequent. If a person buys berries, you can expect him to buy sour cream as well, right? You can expect him to buy whipped cream as well. It is giving you the support and the corresponding confidence. But I'm really, really interested in the high lift value corresponding to this. This is 3.79. The lift value is 3.7. And because I've sorted this by lift value, you can see here I've provided by lift. All the high values of lift will be listed right at the top. And the low values of, as you go down, the lift value goes on decreasing. So you can see this, it has appeared in 89 transactions. So what does this mean? It simply means that people buy berries and they like to eat berries with whipped cream. That's what it means. People like to buy berries and people like to eat berries with whipped cream. Now, how do you interpret 3.79? Very, very important question. How do you interpret this lift value of 3.79? Remember, just now we discussed that a lift value which is bigger than 1, a lift value which is greater than 1 indicates that A and B are positively correlated. Lift indicates the preference to buy whipped cream, given that a customer has already bought berries. I repeat, lift indicates what is the preference of a customer to buy whipped cream, given that he has already bought berries. Very, very important. Now, when you look at the corresponding lift, let me just draw your attention to 3.79. What does 3.79 mean? It means that a person who buys berries is 3.79 times more likely to pick up or purchase sour cream as compared to an average customer. So let me just give you the example of John and Matthew. John is a person who has purchased berries. Matthew has not bought berries. Now, if I go and pitch whipped cream to John, who has already bought berries, John will demonstrate 3.7. John is 3.7 times more likely to buy whipped cream as compared to a customer like Matthew. So lift is a very, very powerful metric in that sense of the word, because it helps you in product placement as well, right? Many times in the store managers struggle which two items should be kept close to each other. Where should we position the items? A very, very simple and an effective way to do this is a lift value which is greater than 1, or lift value corresponding to those products which are very, very high, can help the store managers to decide product placements on the aisle as well. I see, let me just make a move on to the second rule. The second rule is with respect to tropical fruit and other vegetables. If a person buys this, you can expect him to buy pip fruit as well. If a person buys pip fruit or other vegetables, you can expect him to buy tropical fruit, right? Fourthly, people who buy citrus fruit and other vegetables can be expected to buy root vegetables. So this is very, very important. Since the lift value is very, very high, I will take each of these rules very, very seriously. So this is the power of a priori algorithm. When you have millions and millions of product, it becomes a bit difficult to manually identify which item sells best with which other item. A simple trick, a simple way of seeing this would be through the a priori algorithm. Once you run the a priori algorithm on the data set, you will get a whole lot of measures like support, confidence, and lift. Sort it by the lift values. All the high lift values will come right at the top, which is a strong indication that customers have a preference to buy RHS, given that he has already bought LHS. So this is a very, very simple way of doing market basket analysis. Let me just make a move on. In the earlier instance, I sorted by lift. Now, what I want to do is I want to show my audience, instead of sorting by lift, is there an alternative way in which I can show the same rules? Let me just recall the earlier command. Now, instead of saying by lift, what you can do is you can also say by support. You can also say, I want to sort this by support. Please feel free to provide any additional parameters as well. Right. You can see here, it is sorting by support, right? And all the high support values come right at the top. What does this indicate? People who buy other vegetables can be expected to buy whole milk. people who buy rolls or buns, yogurt, root vegetables, that also sort of leads to whole milk. So to whom can you sort of cross-sell whole milk? To whom can you pitch whole milk? As you can look at the LHS here, people who have already bought rolls or buns, yogurt, root vegetables, or other vegetables, you can cross-sell whole milk to these guys. So this is one way of showing the result of the a priori by sorting based on support. Now there is one more thing that you can do, and that is, let me just clear the screen. I'll recall the old command. I'll say inspect. Instead of saying head, what I'll do is I will say sort. Inspect of sort of sort. I'll be sorting the rules by support. This is the first level of sorting. Now, after support, what I want to do is I want to again sort by confidence. So you can use a by keyword and you can say confidence within double quotes. I have opened three brackets, 1, 2, 3. So I'll be using 3 close brackets as well, right? Now, since I'm just interested in the top 5 rules, I can say 1 up to 5, right? So instead of showing me a whole lot of rules, what it will do is it will limit the number of rules to only the top 5 rules. I can close the bracket here. I don't need to give this particular bracket. Right. So what I've done here is I am sorting the rules by support and then by confidence. What you see is very, very interesting here. It shows which all items can be cross-sold with the whole milk. You see something very interesting here. You see curds and yogurt appear here, right? I don't think curds and yogurt were present earlier. Now, what you see is if a person buys curd or yogurt, again, you can cross-sell whole milk to him. If a person buys butter or yogurt, you can again, if a person buys butter and yogurt, you can again cross-sell whole milk to him, right? Tropical fruits, root vegetables lead to other vegetables. Citrus fruit, root vegetables lead to other vegetables. And you have support, confidence, and lift values being demonstrated as well. Now, let me just look at whole milk. The lift value looks very, very promising because it's consistently above 2, right? It's above 2 for whole milk, which means basically, given that a customer has already bought curd or yogurt, a person who buys curd or yogurt is 2 times more likely to buy whole milk as compared to a random customer. Similarly, you can say a person who buys other vegetables and curd is 2 times more likely to buy whole milk, right? Now, let's look at butter and yogurt. You can make the same argument here because the value is 2.5. A value of 2.5 means a person who buys butter and yogurt is 2.5 times more likely to buy whole milk as compared to a customer who is an average customer, who is a random customer. So this is how we can run an a priori algorithm. We can sort of dump the results of a priori algorithm in an object, and you can choose to sort it based on lift or confidence or support. I have come to the end of today's presentation. I thank you very much for watching my video. I request you to subscribe to my channel, The Outlier, and hit on the like button. I'll see you in my next video. Thank you very much.